Then for pieces, for B, a point D, so that we quadrilateral ABCD should be more or less the same also. So we're kind of lost, sir. Well, we're not lost, but like
what?
uh,
For the question A first, what did you guys conclude? Question A. How do you find the area?
the primary triangle method.
Could you demonstrate that?
Like you draw a rectangle around the whole thing, and then you subtract the certain triangles that are outside the triangle but inside the rectangle. So there's this and this, and you get the inside triangle. But
Okay.
Matthew also has some ideas. You have also has ideas.
Sorry, Matthew also have what?
Ideas.
Okay.
Oh, I use AB as a base. I just found the distance between it, and then I found the distance between AC, and I just did half times base times height. So I get square root of 493.
Oh. Okay, meaning that you're using the base times height divided by 2 math formula, is it?
Yeah, that's what I'm using.
Okay, thank you. So you might want to check, Enzo, what you were saying just now, and then what Matthew is proposing. So you might want to check whether the two formulas or the two methods will give you the same answer.
Okay, sir.
Diraf and Darren, how? From you.
I did the same as Matthew one.
You did the same as Matthew. Okay, Diraf?
Yeah, me too, sir.
Okay, so it's 3 versus 1. Interesting. So the thing that you may want to check is this. I did mention earlier that the use of half base times height. Okay, or let me just ask this. According to Matthew, that's the result, right? Half times square root 29 times square root 68. Is that correct? That's Matthew's writing.
Yeah.
Yeah. So square root 29 is AB, is it? Is that correct?
I think square root 29 is AC.
AC. Okay. Can you please take note of that? Put it on the top. So then half times AC times AB, is it? Then only that line. So then people would know that you're referring to that. So you're saying that AC is the base and AB is the height. Is that correct?
I kind of did AB's the height, but I mean you can rearrange it. So yeah, I use
Yeah.
AB
Okay.
as
Yeah.
the
You
base.
can make the AB becomes the base or the AC becomes the height. Correct. So either way, basically you're using AB and AC. My only question is this: when you or when researcher or when people say the height of the building, yes, let's say they say it's a 230 meter. How do they know it's 230 meter? How do they calculate that? Or to make it simple as this, which one do we say the height of the building? Or the tree? It could be, or a person, the height of person. Which one that we say is the height?
The vertical one.
The
Yeah,
vertical
the
one?
Y level.
Is it always the vertical one?
The perpendicular one.
The perpendicular one? Oh, what do you guys think? I don't know. So you could debate on that. The perpendicular one, the vertical one, do they mean the same, vertical and perpendicular? Are they referring to the same thing? Because remember, mathematical formulas are always based on a context. So there should be something that you have to understand first before you actually use it. You can't always I just use this formula. That's it. But you have to understand base, height. What does it mean by base? What does it mean by height? So which one are they? So we cannot just use it for the sake of using it. right? So you have to make sure that you get that right first. Okay, so you might want to think about it first. Let me go to the other breakout room. I'll extend until 3 p.m. Yeah, so 3 p.m. later, come back to the main room.
The same length as AC again, so double the AC. And then we will make that line to the base and the AB into the height. Sir?
Yo, what is it? Yes.
Oh my god, I don't know how to draw in here.
Oh, you don't know how to draw? Draw what?
Like, on the Miro. I'm trying to explain my idea, but I don't. It's gonna be hard without drawing it.
Okay. Where are you? Kayla. Okay. So what do you want to draw?
Extend the CA line downwards until it becomes the same length as CA. So double the CA downwards.
Double the CA downwards. So you extend the CA
Yeah.
here
Mhm.
all the way, is it?
Until it becomes the same length.
So same length of this.
CA.
Okay, and then?
And then just connect it with the B point.
Then it's probably somewhere here. So then I connect it to the B. Connect to the B point. Oops. Then?
So we just we use C and the new point, let's name the point F. CF becomes the base and then AB into the height.
Oh, so this will be your height. You're saying this. Oops, this will be your base. Okay. Okay. So you're still talking about the question A, is it?
Yes.
Okay. And then
We just calculate the length.
the length of FC and the length of AB.
Yes.
Okay. 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 It's already 2:59. So I need you to go back to the main room. We'll be continuing our discussion later over there. Okay. Thank you guys for your discussion. Very interesting one. So let's go back to the main room. Okay. Okay. Sec 3, wherever you are, please come back to this main room. I need to check the other breakout rooms as well. Breakout room 2, breakout room 3. Oops. Guys, you can go back to the main room. I'll see you there. Thank you. Okay, is everyone here already? Please turn on your camera, guys. So we'll be discussing in the remaining 15-20 minutes. I'll be discussing the ideas, your ideas, before we reflect and we try to summarize what we are supposed to learn today. Okay, so I think it's an interesting discussion. You guys could come up with different ideas. Some of you stick on using the formulas, the base times height divided by 2, while some try to develop something else. Okay, so give me one idea. Group 1, give me one idea. How do you find the area of the triangle? What did you guys discuss? including the silly ones is also okay. Anything. How do you find? Yes, JC.
So we come up with two ideas. Number one is just basically you stick the protractor right to the screen, then you measure the 90-degree angle, and then you find the coordinate, and then you just connect the lines so that it'll make a right angle, and then you find the length of both of the two lines, because those are well the base and the height, and then you just plug in all the formulas, and then you'll get an area. But then
Second,
Aaron tried it, and he said that it's kind of inaccurate. So there was the second method from Kyla, which is to extend the line CA downwards, so that you double the CA, and then you connect the endpoint to B, and then you just calculate the formula and stuff.
you're using and then this is using half base height, is it?
Pretty sure, yeah.
Yeah. Okay. Thank you. So did anyone think of that using protractor aside from the group one? That's an interesting idea. Regardless of whether it's correct or not. I don't really care about that because the purpose of our discussion is to enrich our discussion. So then even crazy ideas, crazy methods, just blur it out because they might give us something. Okay, group 3, what method that you're using that you guys discuss?
So we also had two methods, and the one that is used most by most of the group members is also half times base times height. As for the second one, it's using the.
Sorry, wait, Lucy, can you be more specific? So you're using the formula base times height divided by 2. Which one is the base? Which one is the height?
So I'm not sure how the others did it, but for me, AB is the base and AC is the height.
Okay, so I can say half times AB times AC.
Yeah.
Okay.
But I use the AC as the base.
Okay, so anyway, you can swap this, right? So some of us are using AB as the base and then AC as the height, or you put it the other way around. Thank you, Laila. Okay, continue. The second method?
The second method, I'm not sure how the book derived it, but it's inside the textbook.
Oh, you're using the one in textbook.
Yeah.
Textbook method. Okay, meaning that you read the textbook. Thank you. Very well. Okay, this is group 2. Group 3, sorry. Group 2, just an overview of your method. Group 2, what method did you come up with?
The first method, which like many people did, was like Lucy's and the first groups. I used the half times base times height.
Okay.
Either EP or AC as the base.
Okay.
And then the second method was what do you call it? Like the primary rectangle triangle thing. I mean like you draw a rectangle and then you minus a triangle from it, and you get the triangle in the middle.
Okay. The primary rectangle triangle thing. Could you elaborate that a little bit? So what did you do?
You draw a rectangle. You insert the entire triangle inside the rectangle.
So are you saying that we draw the rectangle here, somewhat like somewhere here, like this? Like this, you draw the rectangle over here like this. Not like this, of course. This is awful, a terrible drawing. Like this. Okay. Like this.
Yeah.
And then.
And then you minus the triangles outside the triangle, but still inside the rectangle.
So you find the area of the rectangle first. That's it. And then you minus by the remaining this. Okay. Can you guys imagine that? The rest of you, I mean, I don't know how to put it into words. Enzo mentioned as primary rectangle triangle thing. Okay. Okay. So does anyone want to comment on anything from your discussion? Or probably anyone would want to say like, it's that method is actually interesting. I don't know which method it is. Yes, Kayla.
For the half times AB times AC method, I'm not sure about that method because the formula only applies if the base and height are perpendicular to each other.
Okay.
There's no information that AC is perpendicular to AB.
Okay, so you're not sure about using the half times AB times AC because the note is base must be perpendicular to the height, and we have no information whether AB is actually perpendicular to AC. Thank you. Does anyone want to add on? Or you agree? You could say you also agree with this, or you disagree with that. It's an open discussion. It's a free class. Free class? Free discussion. Diraf, you wanna comment on anything? Usually you voice out your mind. Is Diraf here?
I agree.
Agree with what? With which one?
The method of forming the square, square, and finding the area.
Huh? Sorry, which one? Which method?
The one with the squares or the rectangle.
Oh, the one that Enzo just mentioned, the last one. Inia, the one here. Okay.
Yeah, that one.
Okay, so okay, let me just sum up this because we don't have that luxury of time. So let me just make the summary. So I'm hoping to discuss it a little bit more. So in general, there are a couple of methods that you find. First, you're using the half base height still by referring to half times AB times AC. Some of you did this, though turns out Kila is not sure on whether AB and AC perpendicular or not. So let me just put the question mark over here. That's the first method. I think your method also with the one extending the CA, right, Kayla? So let's just keep that as one method. The second method that Aaron, right, proposed is like somehow visually, just do it visually. So you literally analyze the visual, the analyze actual visual, that's also possible. And then the last method, the third method that we could find is that what is that method? The name. Let me just use Enzo's term: a rectangle, triangle, area thing. You know what it means now. Okay, so the thing with the first method, as you just mentioned earlier, that the note, that the problem is we have to be very sure that the base and height, they must be perpendicular. And I think what Aaron was trying to do also try to ensure that. Is that correct? What you are trying to do is try to find the perpendicular. Is it correct, Aaron? That's why you're using protector, right? Laila and Kayla, yeah.
You try to find the specific point perpendicular to the C point, but
Yep.
That might not always work because the point could be like very specific. Like it's how you say it.
Okay, so basically, yeah, you're trying to find the point in such a way you can use this, basically, right? You will still want to stick with the formula of the half base height. But it turns out it could be, we could use that, but probably it's just too complicated. And I think you mentioned that, in the group mentioned that the answer was not very accurate, which is totally fine. So I think the one that is probably interesting is the last one, what Enzo proposed in the group, using the rectangle, triangle, area thing. Probably let me go back to the primary level mathematics area. Okay, we're talking about area. If I have a rectangle like this, right, and then I want to find this area, the shaded region, what will you do? Let's say I give this is 10, this is 6, let's say this is 2, this is 3. How do you find area? What will you do? There is a first approach, I believe. How do you do? You cut this. I believe your teacher taught that, right? You could cut that. You could cut it this way, or you could cut it this way. It's up to you how you want to cut it. You could, let's say, let me just take this approach. Let me cut it here. So then we know that this part is 6 times 8, right? And then this part is 2 times, this is the remaining. Let's say, let me just change this. This is 2 also. So this is 4. So 2 times 4. So you got 48, you got 8, so you got 56. Some of us are using this method, all right? Or some of us are using what Enzo mentioned. Instead of going through cutting off the areas, why don't we just go through the whole thing first? That might look easier. So let me go through the whole thing, which is 6 times 10. So I got 60. And then that white area on the corner, at the corner, that's just 2 times 2, which is a 4. Why don't we just subtract that? We just take it away. 56. So the very least, we have these 2 methods or these 2 approaches. Now, if we go back to what we're discussing here, okay, though what Enzo mentioned, it's actually not in the question, right? They don't mention anything. They just give this triangle. But we can use our eyes for that, actually, that's actually very interesting. So we can draw this rectangle over here. Let me try to make it better this time, though it's still not good. So we could make this rectangle. Just imagine this is the best rectangle in the world. So let's say we name this. Let's say this is R. Let's say this is A. This is B. This is C. So how do you find the area of R? So the area of R, you could make it by finding the area of the rectangle, which is this is 8. And this is 7, right? 8 times 7. And then you subtract this with area of A, of B, of C. Does that make sense for you? So you go with the whole thing and then you take away. So I don't think that I have to go through everything. I believe that you could sense it already. It's just that a matter of calculation, right? So I could actually just leave it here. So this is half times 5 times 2 and then so on. So you could continue, right? Then after that, what? Basically, you just find 56. You take all these things and then you subtract. Then you get the R. Is that okay? Right? So basically, we can do that way. And in the textbook, this is called the boxing method. I'm not really sure about the name, but oh well. Let's just use the name in the textbook. I'm not really sure about the name though. So they call this the boxing method, which that could bring us to the second question. Let's say if we at a point D over here, 8, 7. Let's say where is 8, 7? 8, 7 is somewhere here. So this is the point D. In such a way, you could create a quadrilateral. And then the question is, can that method that we use be applicable here? Can that method that we use, can this boxing method still be used? What do you think? So you still make the rectangle like this. We have no issue with this one, right? We have no issue with this one. So this is still okay. It's okay. The problem is this one. How do we cut this part? Can we cut it here like this? Will that be okay? So you have this, let's say, so this area B, instead it becomes area, the B will be here and the D will be here. So separated by, so this small triangle and triangle. And that will bring us to the next question. If it's random polygon, can you still use it? Just by sense. Can you still use it even if it's a random polygon? So what I mean is this. So let's say we have just it's not quadrilateral anymore. Let's say it looks like this. Can we still treat it in such a way? Oh, is this actually a rectangle? Then we cut the triangle anywhere. Does that make sense? Can we still use it? Probably. We're not really sure, right? Probably, but we're not really sure. Some of us were like, yeah, maybe, or probably some of us are like, yes, we can. So that's the method that I want to introduce to you, basically. Now, I want to cut it short. If you read your textbook on page 148, 149, they actually introduce a method that Lucy mentioned, the one that I said, the textbook method. So, which I do not want to discuss this in a great detail, but if you see here, there are so many writings on the right side here. That's basically I'm trying to derive or prove it, show how it works. This is how it could be done, actually. So this, if you see the x1, x2, x3, and blah, 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 like so complicated, basically this is how we could get that formula. So if you're wondering that formula, how do we could come with that formula, this is somewhat how I derive it. But simply speaking, you don't have to memorize or remember that. Simply speaking, the formula or the method is called Shoelace Method. Why? Because it looks like a shoelace. So let me show you how it's done. Okay, so let's say in the case of this, okay, let's go back with our question. In our question, tell me what's the coordinates. What is the A? What is the B? What is the C? The A is 1, 3, right? The B is what else? 9, 1, right? And the C is 3, 8. So this shoelace method basically say this. The shoelace method. Some textbooks say shoestring. And then the way they put it also not like the one in your textbook. So the way we put it this way: area is half a triangle, right? So half times, we put it this way. You just basically put it in order. So 1, 3 is 1, 3, and then 9, 1, 9, 1, 3, 8, and then you repeat. You go back to 1, 3. So you repeat this. So this is how technically we use it. Then what do we do? What do we do is basically just like this. So half times multiply, multiply, multiply. Okay, let me demonstrate that. So half times 1 times 1, which is 1. 9 times 8, which is 72. 3 times 3, 9, right? And then what we do next is we multiply this, this, and this, but it will be negative. So it will be negative 27, negative 3, negative 8, right? Then we calculate, basically. So half times, you do whatever inside first. Usually, the formula usually put it this way. So 1 plus 72 plus 9 minus bracket 27 plus 3 plus 8. Some put it this way. So you go with half times 82 minus 38. So this will be half times 44, which is 22 square units. And that's it. The way how do we derive it, you have to read through that. I'm not going to explain that because that's beyond our discussion. It will be too long for that. Okay? So this is how the Shoelace method is used, which actually the Shoelace method comes from this boxing method. It's interesting, right? I mean, like, that's how we actually question simple things. Oh, I'm using boxing method. How if I take it general? How is if the coordinates are not like this? Can I still use the boxing method? Turns out you can. And what do you get? Shoelace method. Okay, so with that, let me just give you this question number 3. This is end of lesson assessment, which both questions I take it from the textbook. So let us go through this together. So question exercise 7.4 number 3. So you do this, you already do the one of the suggested exercise or problem. Triangle PQR. The P is 1, 4. The Q is -3, -4. The R is 7K. It said that the right angle at Q, like what I mentioned, when we're talking about geometry, it's always good. It's best. It's better that you make some sketch to give you an idea. Do you have to? Actually, no. But it's just good if you could do that. So if you make just some random sketch, this is 1, 4. So this is the P. The Q will be somewhere here, right? And the R will be 7. 7 probably here. So 7, I don't know where should it be. But at least you know this is P and Q over here, right? And then it is mentioned that the right angle at Q. What does it mean? Right angle at Q. That means the perpendicular must be like this, right? Because the R should be based on 7K, so this must go this way. Does it make sense? If not, then they will not mention the R will be 7K. So this should be the right angle here. So roughly it will go something like this. This will the triangle look like. So PQ, QR, perpendicular. The question is the K. What do you think that we can do? What should we do? We have to find the value of K. The best that we know is right angle. If it's right angle, perpendicular. If it's perpendicular, what concept that is connected? About line. That we already discussed.
Gradient.
Gradient. Very good. So we can use the idea of gradient. So let's find the gradient of PQ and let's find the gradient of QR. The gradient of PQ will be -4, -4 over -3, -1. So -8 over -4. So it's a 2. QR instead is K plus 4, 7 plus 3. So K plus 4 over 10. Then we could know that PQ and QR perpendicular, right? So that means 2 times K plus 4 over 10 must be -1, based on our theory, right? Or K plus 4 over 10 must be -12. In other words, we could go through 2 times, let me take the easy way. So there's -5, so the K will be -9. If you check by using GeoGebra, you will get 9 also. Then, now, we get the PQR, right? We get the P is 1, 4. We get the Q is -3 and -4. We get the R is 7, -9. So, what's the area? By the Shoeless method, you could try. I'll give you time to try it. Okay, 2 minutes. Use the Shoelace method. So you write the half. Write it this way. And 1, 4, -3, -4, 7, -9. Then always go back to the beginning. So 1, 4 again. It's always like that. Then some of us might ask, sir, if I use the Q first, will that be a problem or not? Or if I write the R first, will that be a problem or not? No, it will not be a problem. The only problem is that you will get a negative value. Then if negative, then how? It's okay. If it's negative, we know area shouldn't be negative, right? It just doesn't make sense, right? Then that means actually the formula says it's actually absolute value, modulus. Okay? So this will be multiplied, right? Multiplied. They're all positive. And then the other way around, we multiply, but it's all negative. So what should it be? Tell me. What should I put the number here? Yuraf, can you help me? The number here?
I'm thinking.
Sorry, can you repeat? It's too soft.
I'm thinking.
Oh, you're thinking. Sorry. So 1 times -4. What is it?
-4.
-4, because it's positive, so just keep it that way. -3 times -9, which is
27.
27. 7, 4,
28.
28. Then you go with subtraction, minus here. For me, I prefer to do it this way, minus and then bracket. Then I just multiply. 4 times negative 3, negative 12, negative 4, 7, negative 28, negative 9 and 1, negative 9. This is what I prefer. But some of us might prefer 4 times negative 3, negative 12. They give the negative again, so 12. But some that could be confusing for some. So I usually prefer this way. And then half times 51 minus negative 49, which is that will half modulus of 100. Modulus of 100 is positive, right? So it's just 50. So we're done with that. Okay, so questions? What questions do you probably have? Yes, Kayla?
So for the shoelace method,
Yep.
Can we do it in any order?
Yes. Let me just see, right? I just talk about it and then you ask. Let me show it. For the rest of you, if you think that you're okay with this, then you want to go through with the other, go ahead. We only have about 2-3 minutes left. Let me just show you. For example, I put it half and then negative 3, negative 4 first. Then 1, 4, 7, negative 9, negative 3, negative 4. This is trial. Okay, then let's do it. Half, then we do the same thing, right? This first, plus, plus, plus. So we get negative 12, negative 9, negative 28. And then, where's my cursor? And then this, and this, but they all should be negative. So for me, I'll do it subtraction by negative 4 plus 28 plus 27. I'm going to put it this way, right? Then let's do the calculation. So we get half. This is negative 49 by calculator, right? Subtracted by 51. You see? What do you get inside? What is this, Kayla? Negative 49 minus 51. Negative 100, right? Which is, that's weird. So then if you think like, oh, so then it's a problem now. So I did this incorrectly. No, it's totally fine. So the note is that it should be modulus, absolute value, so that you still get half of 100, which is will give you 50. So it's still the same answer over here. Sorry. Do you see what I'm trying to say? So you could swap the order, which is totally fine, but just make sure that you always keep it positive. So that's a shoelace method, or shoestring method, some people would say. If you browse it online, they would put it a bit differently. They put it, instead of going horizontal, they go vertical. So it's more like a shoelace. This doesn't really look like a shoelace. But if you try to Google it somewhere, they have their own resources, then it looks more like a shoelace. Okay. Before we end, so what I want you to do, though there are many exercises that you could do, I want you to do I just give you two exercises that I hope at least that you could submit. First, this one, the one on the assessment, and the other one is exercise 7.4, number 1B. Sorry, number 1B. So in that sense, it will be here. There's 1 and the number 6. Okay. If you already submit, if you try to do the question number 6 already, that's very good already. Number 1 is just to review the Shoelace method. Okay. So with that, thank you. Should you have any question, do address it in the next meeting. We still have the next meeting before I continue with the next part of the chapter. Should you have anything that you want to ask, you may stay after this, then we could discuss it further. Okay. So thank you, guys. Thank you, everyone. Hope you have a good rest. Thank you. Bye bye.